Welcome to AI Unboxed, from hype to reality. In this short series, we'll cut through buzzwords and focus on what AI actually delivers today, who benefits, and what leaders need to know. Over the next modules, we'll move from basic concepts to technical building blocks, real-world use cases, risks and ethics, and practical steps your organization can take to capture value responsibly. This content's overview maps our journey. We start with the AI awakening, then peel back the engine under the hood, explore real-world payoffs, and examine ethics and risk. Finally, we look ahead to future opportunities and concrete actions you can take. Think of this as a roadmap to understand both the technology and its business implications in plain terms. When we say AI today, we mean data-driven systems that perceive, learn, and act. Most commercial systems are narrow AI designed for specific tasks, while general AI remains aspirational and research-focused. AI sits inside computer science, built from algorithms, data, and hardware, and understanding these layers helps set realistic expectations about what current systems can and cannot do. AI's story starts with symbolic logic and expert systems in the 1950s, which laid the groundwork despite early limitations. Fast forward through statistical learning, and recent advances in deep learning and foundation models transformed capabilities. That historical arc explains why we now see powerful tools, and also why continuous research and careful deployment remain essential. Data is often called the lifeblood of AI, but that doesn't mean more data automatically equals better outcomes. High-quality, well-labeled data drives performance, while privacy, regulation, and labeling costs complicate things. Choosing between open and proprietary datasets involves trade-offs in cost, accessibility, and specificity, so organizations must balance quality, compliance, and value when building datasets. Let's demystify the algorithms. Supervised, unsupervised, and reinforcement learning each solve different problems, from classification to discovery to decision-making. The transformer architecture revolutionized language and vision tasks by handling sequences efficiently, and hyperparameters like learning rate and batch size critically shape model performance. Together, these pieces determine how well an AI system learns and generalizes. Compute choices matter. Specialized hardware like GPUs accelerate training but add significant cost, while cloud solutions give flexibility and edge devices bring latency and privacy benefits. AI models also consume energy, so sustainability and efficiency are increasingly important considerations. Balancing cost, scalability, and environmental impact is a key part of responsible AI strategy. Across sectors, we see clear wins and real warnings. In healthcare imaging, AI improves diagnostic accuracy but demands rigorous validation to avoid bias. In fraud detection, AI identifies suspicious patterns, yet requires ongoing tuning to limit false positives. In manufacturing, predictive maintenance reduces downtime, but hinges on data integration. Creative media is being transformed, though copyright and authenticity create ethical challenges. For leaders, think in terms of ROI through a simple framework. Ensure a clear problem-solution fit, so AI addresses real business priorities. Assess data readiness to confirm you have the quality and access needed, and evaluate risk-adjusted returns by accounting for technical challenges and market shifts. This approach helps prioritize projects and allocate resources sensibly. Bias in data often reflects societal patterns and can produce unfair outcomes if unchecked, so identifying and mitigating bias is essential. Fairness needs measurable metrics tailored to context, and explainability tools help make models transparent for compliance and trust. Combining these practices supports ethical deployment, especially in high-stakes areas like finance and healthcare. AI systems face security and misuse risks, from adversarial attacks that perturb inputs to cause wrong outputs, to broader misuse when systems are deployed without safeguards. Robust defenses, adversarial testing, and keeping humans in the loop for oversight are practical ways to increase resilience and ensure accountable, ethical use of AI in production environments. Looking to the next wave, several research frontiers could reshape the landscape. AGI research explores broader cognition, quantum computing promises potential optimization speedups, and neuromorphic hardware aims for brain-inspired efficiency at the edge. Executives should track research, industry signals, and regulation so they can prepare for disruption and seize early opportunities responsibly. A practical roadmap starts with governance. Form a cross-functional AI council to guide strategy and align perspectives. Conduct a thorough data inventory to surface gaps and opportunities, and run 2 focused pilot projects to learn quickly and validate impact before scaling. These steps build momentum while keeping risk manageable and outcomes measurable. To wrap up, start with clear problems, invest in high-quality data, embed ethics by design, keep humans in critical decision loops, and scale only after measurable success. Begin with small, well-defined experiments to build internal capability and confidence, and use those wins to drive broader adoption while staying mindful of risk and fairness. Thank you for joining this session on practical AI adoption. We hope this series gives you clarity on how to separate hype from reality and actionable steps to move forward. Explore the related modules for deeper dives, and consider which small experiments you can start this quarter to begin capturing AI's potential responsibly.